WANs in the OSI model. We've not talked about the OSI model in the last chapter. Let's talk about it now. WAN access standards typically describe both physical layer delivery methods and data link layer requirements, including our physical addressing, the flow control, and encapsulation. So here at the data link layer, we have HDLC, PPP, frame relay, Ethernet WANs, MPLS, VSATs, and broadband. And then at the physical layer, it's the electrical, mechanical, and operational connections. With our layer 1 protocols, they describe how to provide the electrical, mechanical, and remember physical is layer 1. And then at layer 2, it defines how data is encapsulated for transmission toward a remote location. One of the primary differences between a WAN and a LAN is that the company or organization must subscribe to an outside WAN service. Again, it's what we have to purchase. We have the customer premises equipment, that is the device and inside wiring located on the enterprise edge connecting to a carrier's link. We have the data communication equipment, or the DCE, also called the data circuit terminating equipment. And the DCE consists of devices that put data on the local loop. The DCE primarily provides the interface to connect subscribers to the communication link on the WAN cloud. Then we have our DTE, that's the data terminal equipment, and this is the customer devices that pass the data from the customer's network or host computer for transmission over the WAN. And the DTE connects to the local loop through the DCE. We have our demarcation point, and that is the point that's established in a building or a complex to separate customers' equipment from service provider equipment. Physically, the demarcation point is the cabling junction box located on the customer premises. So that's like where your cable box comes in, but for a corporation, it's a little bit bigger. We have our local loop, and that is the actual copper or fiber cable that connects the CPE to the CO, or the customer premises equipment to the central office. The local loop is also sometimes called the last mile. Then we have central office, and that's local service provider facility or a building that connects your CPE to the provider network. Then we have a toll network, and that consists of the long haul, all digital, fiber optic communication lines, switches, routers, and other equipment inside a WAN provider's network. Okay, so that's not our network, but that is the provider's network. There's many different types of devices that a specific WAN environment, including you have your dial-up modems. Yes, they're still out there. It is legacy, but some of them do still exist. You have your access servers. They concentrate dial-up modems, the dial-in and dial-out user communication. It's considered to be legacy today, but again, some people still have them, so you have to be aware of them. You have your broadband modem. You have your CSU, DSU. That is your digital lease lines, require a CSU and a DSU, and they can be a separate device like your modem, or they can be individual. You have your WAN switch, you have your router, you have a core router or multi-layer and a multi-layer switch. These are just some of the devices. There are other ones that exist, but this is just a good overview. Our switched network is one that establishes a dedicated circuit or a channel between nodes and terminals before the users may communicate. Specifically, our circuit switching dynamically establishes the dedicated virtual connection for voice and data. You can click here to see an example of the dialing sets up a physical connection through the system, because A is dialing B, so it's making its connection until it gets to B, and that's where it rings. As you can see here, the two most common types of circuit switched WAN technologies are the public switched telephone network, or the PSTN, and the integrated services digital network, or ISDN. With WAN technologies, let's also look at our packet switched networks. The switches in a packet switched network, or a PSN, determine the links that the packets must be sent over based on the addressing information in each of the packets. We have a connectionless system, and then we also have a connection-oriented system. With connectionless systems, you have full addressing information must be carried in each packet. So each switch must evaluate the address to determine where to send the packet next. An example of connectionless is the internet. Connection-oriented systems predetermines the route for a packet, and each packet only has to carry an identifier so that it knows where it's going. The switch determines the onward route by looking up the identifier in the tables held in memory. So it has a table of this information. The set of entries in the table identifies a particular route or circuit through the system, and when the circuit establishes this temporary route while the packet is traveling, and then it breaks it down again, and it's called a virtual circuit, or a VC. An example of this is frame relay. So let's look and see how this looks. We've got a labeled data is passed from switch to switch, and it may have to wait its turn on a link if there's other information going. So here's a good example.